Let's practice with the empirical rule. So first things first, we're talking about Professor Ivy collecting data on the time it takes students to travel to school. The mean is 27.5 minutes with a standard deviation of 5.2. Hit pause and fill in the data. Remember, the mean always goes first and it's in the middle. So as I mentioned, the mean goes in the middle. We're going to add 5.2 each time we move to the right, and we're going to subtract 5.2 every time we move to the left. That allows us to use this to answer some questions. So what is the interval of commute times in the middle? 99.7%. Remember, the empirical rule is 68, 95, 99.7. 1 standard deviation, 2, 3. So we're looking for 3 standard deviations away from the mean. So 1, 2, 3. High side is 43.1 minutes. 1, 2, 3. Low side is 11.9 minutes. So the interval is 11.9 to 43.1. What's the probability of commute time being more than about 38 minutes? Well, this is about 38, so more would be to the right. Remember, this is 2.35%, and this little spot is 0.15%. So if I add those together, 2.35 plus 0.15 gives me 2.5%. Based on this data, how many students out of 500 would we expect their commute time to be less than about 12 minutes? Well, here's about 12. Less than that is 0.15%. So we're looking for 0.15% of 500. So let's change this percent to a decimal by moving it left 2 places or dividing by 100. Multiply that 500 and we get 0.75, which is approximately 1 student. So about 1 student out of 500 would expect their commute time to be less than 12 minutes. All right, new question. We're talking about birth weights. Now we've got a mean of 7.47 pounds and the standard deviation of 1.21. So mean in the middle, and we add going to the right. So 8.68. We subtract going to the left, and you continue to do that. So what are we at? There's my numbers. Mean in the middle. Remember, we're adding standard deviation to the right every time. Subtract standard oops, put my decimal in the wrong spot there, didn't I? We subtract the standard deviation going left. Okay, so we have our numbers. Let's answer some problems. 95% of the weights are within 2 standard deviations of the mean. Therefore, the middle 95% of birth weights are between what values? So here's my mean. 1, 2. My top number is 9.89. 1, 2. My bottom number is 5.05. So 95% of birth weights will be between 5.05 and 9.89. What's the probability a birth weight will be less than about 5 pounds? Well, here's about 5 pounds, so less than is this direction. So the little piece is 0.15%. The next piece is 2.35%. So together, that is 2.5% chance that a baby will weigh less than 5 pounds at birth. What's probability a baby will weigh more than 5 pounds? Well, remember, if this is 2.5 pounds over here, everything else is more. So 100% minus 2.5% gives me 97.5%. How many babies out of 1,000 would we expect to weigh more than 11 pounds? Okay, here's 11. More than that is 0.15% of 1,000. Okay, so we change this to a decimal by dividing by 100 or moving it left 2 places. 0.0015 times 1,000 gives me 1.5. So I would say that's approximately 2 babies out of 1,000 we would expect to weigh more than 11 pounds. That's it.